Okay, this is the next unit in geometry. It is Unit 6. It's called Right Triangle Trigonometry. And this is Lesson 1. Lesson 1 is called Operations with Radicals. Now, this entire lesson should basically all be review from Algebra 1. But I'm just going to pretend you haven't learned it yet and just teach it normally, because I think some of you have not learned this yet. Okay? A radical sign is used to indicate a root. Okay? So, for example, this is a radical sign. Okay? See right there, radical symbol. That's the radical symbol. The number under the radical is called the radicand. That's denoted with the letter Y in this diagram, okay? But the number under the radical, or variable, or whatever's under the radical, that's called the radicand, okay? So this is the radical symbol, and this is called the radicand. And the index gives the degree of the root. So that's the index right there. If there's no number written as the index, then it's implied to be a 2, okay? So for our lesson, we're going to focus on square roots. But you could also have cube roots, you could have fourth roots, fifth roots, sixth roots, seventh roots, and so on. Okay? But if there's no index, then it's implied to be a 2. Okay? So like I said, we're going to focus on square roots. Okay? The square root of a number is a value that, when multiplied by itself, gives you the number. For example, the square root of 25 equals 5, because 5 times 5 is 25. Now, there's a few ways to solve these problems today, but we're going to use perfect squares because I think that's the best way to do these. I think that's the most helpful way going forward. Okay? A perfect square is a number that is the product of an integer multiplied by itself. For example, 1 is a perfect square because it equals 1 times 1. 4 is a perfect square because it equals 2 times 2. 9 is a perfect square because it equals 3 times 3. 16 is 4 times 4. 25 is 5 times 5, and so on. I went all the way up to 15 times 15 is 225. And I think you should memorize these, okay? Actually, no. You should memorize these. I'm not going to say I think. You should definitely memorize these numbers. Up to like 225, that'd be good. It's just going to make it much easier for you in the long run if you just have these memorized, okay? All right, now let's get to the examples. Okay, simplify the square root of 45. Okay, so here's what I'm going to do. On the side, I'm just going to copy down the list of perfect square numbers from the first page. So I have them memorized so I can go quickly, but let's pretend you forgot the perfect square numbers. Just go through them in your head. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on. But if you have them memorized, it'll go much faster for you. So I have them memorized. I'm just going to go quick now. 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Memorize up to 225. That should be good. Should be good enough. Okay, so the question is, which one of these numbers is a factor of 45, and find the biggest one. If you don't use the biggest one, then you're going to have to simplify twice, and you don't want to simplify twice. You probably just want to simplify once. So 1 is a factor of every number, but that one's meaningless. You can basically ignore the 1. 4 is not a factor of 45. If you don't know how to check that, then what you have to do is in your calculator, do 45 divided by 4 and see if you get a decimal or not. Since 45 divided by 4 is a decimal, then it means 4 is not a factor of 45. 9 is a factor of 45. Let me just check that one off. 16 is not a factor of 45. 25 is not a factor of 45. 36 is not a factor of 45. 49 is bigger than 45, so it cannot be a factor. So the biggest number that's a factor of 45 from this list of numbers is 9. So what I do is I'll rewrite the square root of 45 as square root of 9 times square root of 5, because 9 times 5 is 45. And then I break down the square root of 9 to 3 because the square root of 9 is 3. So this is the final answer. This is simplified. I cannot simplify that anymore because I cannot simplify the square root of 5 from this list of numbers. Okay? Let's try another one. Simplify the square root of 48. Again, try to find the biggest number from this list that's a factor of 48. 1 always works, but you can ignore 1. 4 is a factor of 48. 9 is a factor. 9 is not a factor. 16 is a factor, and that's going to be the biggest one. I know that already. 25 is not a factor of 48. 36 is not. 49 can't be because it's bigger than 48. So 16 is the number you want to use for this one. So I break down the square root of 48 into square root of 16, square root of 3. Then the square root of 16 becomes 4. So the final answer will be 4 square root of 3. Simplify 3 times square root of 50. So you want to find the biggest number from this list that's a factor of 50, and it's going to be 25. So I'm going to leave the 3 in the beginning, just like normal. I'll leave the 3 there. And I'll break down square root of 50 into square root of 25 times square root of 2. And then the square root of 25 is 5. A lot of times people put the square root of 5 by accident. The square root of 25 is just 5. And then we have 3 times 5, which are going to make 15. So the final answer, when we simplify this one, is 15 square root of 2. Simplify 7 times square root of 128. The biggest number from this list, that's going to be a factor of 128, is going to be 64. So I'm going to leave the 7, and I'll rewrite 128 as square root of 64 times square root of 2. And the square root of 64 is 8. So this is 7 times 8 times the square root of 2. And then you're going to make 7 times 8, 56, square root of 2. One more on this page. Simplify the square root of 300 from this list of numbers. The biggest one that's a factor of 300 is 100. So I'll leave the negative 4 there. That's not a problem. I'll rewrite square root of 300 as square root of 100 times square root of 3. And the square root of 100 breaks down to become 10. So negative 4 times 10 times square root of 3. So negative 40 times the square root of 3. That's it for that page. Okay. Adding and subtracting square roots. You're going to use the same ideas as like variables. The radicands, in other words, the number under the radical, must be the same for you to add and subtract them. Okay? So this one says simplify if possible. 2 times the square root of 3 plus 5 times the square root of 3. Okay? Again, think about it like these are x's. If I said what's 2x plus 5x, that equals 7x. Not 7x squared. Okay? So same thing here. If I say 2 square root of 3 plus 5 square root of 3, that equals 7 square root of 3. And that's the answer. Okay. Simplify if possible. 4 times the square root of 5 plus 3 times the square root of 7. And this one is not possible because the radicands are not the same. This radicand is 5, that radicand is 7. If I said do 4x plus 3y, you can't really combine those and simplify them. So I'm going to say not possible, already simplified. The radicands are not the same. You cannot simplify them anymore. Simplify, if possible, 5 times the square root of 3 plus 2 times the square root of 75. So at first glance, you may think this one is not possible to simplify, but this is not amateur hour. We just did one example that was not possible to simplify, so I'm not going to give you 2 in a row like that in the notes. So what you have to do is you have to simplify the square root of 75, and that's probably going to give you a common radicand. Okay, so I'm going to simplify the square root of 75 like we did on the last page. I'm going to use 25 from this list of perfect square numbers. Okay, so I'm leaving 5 square root of 3 alone, and I'm simplifying the square root of 75 down to square root of 25 times square root of 3. Now you probably see where I'm going with this, but I'm going to make the square root of 25 5. And then I'll make 2 times 5, 10. So 5 square root of 3 plus 10 square root of 3. And now, as you may have expected, the radicands are the same. So you can combine these and make it 15 square root of 3. On to the last page. Multiplying and dividing square roots. Okay, these are the hard ones, I think. For multiplying and dividing square roots, simply multiply and divide the numbers outside the square roots and multiply and divide the numbers under the square roots. Square roots are not allowed in the denominator of fractions. You must remove this by a process called rationalizing the denominator. Okay? I'll explain why later. But for example 1, what you're going to do is you're going to multiply the numbers outside the radicals together. So for example, you're going to do 5 times 7. You don't have to do this step. Some people like to write them next to each other, and they like to write the radicands next, numbers under the radicals next to each other. You don't have to do that, but you can. What, 5 times 7 is 35. Square root of 3 times square root of 6, you can combine those under one radical and make it square root of 6. Okay? Square root of 3 times square root of 2 is square root of 6. This is my final answer because I cannot simplify the square root of 6 anymore. How about example 9? And you don't have to do this if you don't want to, but some people like to write the numbers under the radicals next to each other and the numbers not under the radicals next to each other. So some people like to do this. You can do it if you like. If you don't like it, then don't do it. 2 times 3 is 6. I'm going to multiply the radicals together. You could simplify each one separately and get to the same final answer as me. But if you do 18 times 8, you get 144. That's a perfect square number. That's on our list of perfect squares. The square root of 144 is 12. So this is equal to 6 times 12, which is 72. Okay. This next one, simplify the square root of 16 over the square root of 25. Now, there's 2 ways to think about this. You can break apart the square root and think of it as square root of 16 divided by square root of 25, and then simplify each one separately. So the numerator becomes 4, and the denominator becomes 5. And that's the answer for that one. So that one wasn't actually that bad, because both the numerator and the denominator were perfect squares. So that one wasn't that bad. Simplify square root of 27 divided by square root of 36. There's 2 ways to do this. You can simplify the original fraction if you want. I'm not going to do it that way. I'm just going to break apart the fraction and the square root. So I'll make it square root of 27 divided by square root of 36. Simplifying the denominator for this one is easy because that's just simply 6. Because the square root of 36 is 6. 36 is a perfect square. It's on our list of numbers. Memorize that list, please. Simplifying the numerator is not as easy. If you simplify the square root of 27 from this list of numbers, you're going to use square root of 9. Square root of 9 becomes 3. And then you're going to simplify 3 over 6 to make it 1 over 2. And you're going to leave the radical. Okay. Okay. 2 more examples. Simplify 7 over the square root of 5. So like I said earlier, square roots or radicals of any kind are not allowed in the denominator. Why? Well, in math, we like to write things the same way. So let me pose this question to you. I'm writing down 2 numbers right now. My question to you is, which number is bigger? Which one of these 2 numbers is bigger? Do you know or do you not know? Most people will just take a guess, or they'll say, I have no idea which one is bigger. And that's understandable, because these are actually the same exact number, okay? But they're written in 2 different forms, so it makes it very hard to compare them. So in math, we like to write everything the same way. So if these are your answers, this answer is accepted, and this answer is not accepted because square roots or radicals of any kind are not allowed in the denominator. So what you have to do is you have to do a process called rationalizing the denominator. So for this example, we have 7 over the square root of 5. That is not allowed for a final answer because you cannot have a radical in the denominator. So you cannot simplify the square root of 5 from the list of perfect square numbers I gave you earlier. So what you have to do is you have to multiply by this number over itself. So in this case, I'm going to multiply by square root of 5 over square root of 5. And the reason why I'm doing that is because in my numerator now I have 7 times square root of 5. But I no longer have a radical in my denominator because the square root of 5 times the square root of 5 is just 5. Any square root of a number times the square root of the same number is just the number without the square root, okay? So the square root of 8 times the square root of 8 is 8. The square root of 15 times the square root of 15 is 15. The square root of 87 times the square root of 87 is 87, and so on. Think about it like this. The square root of 5 times the square root of 5 is the square root of 25, which is 5. Okay, one more like that. Simplify 12 over 2 square root of 3. A couple ways you could do this one. If you want, holy voice crack, holy moly. Okay. If you have 12 over 2, you could just simplify it right away and say that's 6. So what you're going to have to do, you could do that if you want, you don't have to. But what you're going to do is you're going to multiply by this over itself again. So my numerator becomes 12 square root of 3. My denominator becomes 2. Square root of 3 times the square root of 3 is 3. We just talked about that. So this is going to equal 12 square root of 3 over 6. 12 divided by 6 is 2 square root of 3 for the final answer. Okay. So again, this is that was a tricky lesson, and this unit in general is probably the hardest one we're going to do this year in geometry. But it's a good introduction. We're going to use radicals throughout the entire unit, so you definitely have to know radicals. My biggest suggestion to you is make sure you memorize the list of perfect square numbers. Okay? It'll make it much easier going forward.